Welcome back, folks. In today's class, I'm going to talk about the next chapter, that is chapter number 12, that is magnetism. So, in the magnetism, the first thing we're going to try and do is we're going to try and study about the magnet. So, this is a bar magnet. It has two poles. One is the south pole, and another is the north pole. I should draw the north pole on the right side and south pole on the other side. You can draw it on any side. It just works a little better for me because that's how I always draw it. This is a representation of a magnet, and with the magnet there are magnetic lines. Same way as remember when we talked about when we talked about the charges, there were negative charge and then there was a positive charge, and the electric field lines always move towards the negative charge, and from the positive charge, electric field lines are always away from it. So if these are the electric field lines for a positive charge, they will always be away, and they will always be in towards a negative charge. So if I combine them, how can I draw that? Negative and a positive. So coming out of the positive and moving towards the negative charge. And the same way, the magnetic field lines, they come out of the positive end, or the north end, shall I say, from the north, and they move towards the south. And again, from here, these are the magnetic field lines. So again, I'll draw one more, and this is one more. Notice whatever magnetic field lines which I'm drawing, they will not intersect each other. What do I mean by that? So if this is the north pole and this is the south pole, and this is one of the magnetic field lines, this is another magnetic field line. If I try and draw another one, so it cannot be like this. So these two lines are intersecting at this point. So that's never gonna happen in case of magnetic field lines. Same as that's never gonna happen in the electric field lines too. So that was about the magnet. So remember, one of the things that magnetic field lines always start from the north end, goes out of the north end and move to into the south pole. And another thing, as I said, the magnetic field lines never intersect, and magnetic field lines are always denser closer to the pole. So here the magnetic field intensity will always be closer, and if you keep on going away from the magnet, the magnetic field intensity will reduce. And that's what happens. So if you're trying to pull an iron with the help of a magnet, this is magnet and this is iron. So if you're trying to pull this iron towards this magnet, closer you're going to get, uh, more chances are that you will be able to attract this iron towards the magnet. And if you're away from this, if the magnet is away from this iron, then the effect won't be that much. All right. So this was about the magnet and magnetic field lines. Now, the next thing we will try and study is how the magnetic field plays a role in the electricity. So remember what happens in the electrons. So electrons in a wire flow from one end to another. So if these are the electrons, they will flow from one end. Let's say this is the negative end, and they go towards the positive end. So electrons are flowing in towards the right side in this case. Now, when the electrons start flowing, there will always be a magnetic field around this flow of electrons. So in a wire, if there is a current, in simple words, if I have to tell you, if there is a current in a wire, then there is always a magnetic field. If there is no current, means electrons are not flowing, then there won't be any magnetic field. And how it was figured out, there was a scientist, his name was Hans Christian. He was a Danish scientist, and he was conducting a research work with his student. And in his research work, he figured out, he placed a magnet on his table. There was a magnet placed near his electrical experiment, and whenever he was doing the electrical experiment, he was switching on the bulb and switching off the bulb. What happened was, this magnet showed a deflection. So he was curious to know, and that's what we're going to study, how he was able to figure out that in which direction magnetic field is. And he was curious that why this is showing a deflection. I couldn't complete that statement before. So now, because of that curiosity, he then later on did his research work and figured out how the magnetic field is produced around moving electrons. When the electrons are moving, how magnetic field is produced. So let's say this is a wire in which electrons are flowing, and this is the positive end of the wire, and this is the negative end of the wire. The smaller end is always the negative end. Now the electrons are flowing from the negative end in this direction and moving into the positive end, and that's how always the electrons flow. Go star comes out of the negative end, moves towards the positive end. Now I wanted to find out if I place a magnet near it, as soon as I switch on the current and the electrons start flowing, this magnet will start showing the deflection. And I wanted to find out in which direction the magnetic field is. So that can be figured out by left hand thumb rule. Left hand thumb thumb rule. So now I'm going to try and study this thing up here with the help of a diagram. With this, oops. So if I go back in here, this is the diagram I'm going to try and study. So here I'm going to try and draw the electrons one more time. Electrons are moving in this direction. And the magnetic field, as I said, left hand, thumb rule. So place the thumb in the direction of the flow of electrons. Place the thumb of your left hand. Just before I start doing this one, I just wanted to give you guys a heads up. If you're going to start watching the YouTube videos, and some of the YouTube videos, they are saying the current flows in the opposite direction to the flow of electrons and blah, blah, different things. And they end up using the right hand rule also. So I'm not using any right hand rule. You can, if you wanted to use the right hand rule, go ahead and use that. But this book, which we are using, Alberta grade 12 book, this does not use any right hand rule, so I'm refraining from that. All right, so the electrons are, what I'm going to do is I'm going to place the thumb of my left hand. So uh, this is my hand. I'm going to try and draw the picture as much as I can. So this is my left hand, and the thumb will point in the direction of the flow of electron, and then I'll start curling my fingers. This is my palm. I should be able to see my palm. Okay, this is not the back of the palm, this is palm. Okay, now I'll try and curl the fingers. In which direction the fingers will be curled? Fingers will be curled in this direction. You will find that. So the direction in which your fingers will be curled, that will be the direction of the magnetic field. First of all, magnetic field will always be perpendicular to the flow of electrons. So electrons, if the electrons are flowing in this direction, magnetic field will be in this direction. So the blue line which I'm drawing, that will be the space for the magnetic field, okay, at 90-degree angle. So this is how I can place a 90-degree angle. All right, now within 90-degree, how the magnetic fields line will be. So magnetic field line are in a circular direction. Okay, now, next question comes, in which direction the flow of magnetic field lines is, how, in which direction they are moving. So as I said, you curl your fingers, that will give you the direction of magnetic field lines. Now, here is a question I'm going to ask you guys. If the, let's say, if the electrons are flowing downwards now, so I'm going to change this one as a negative, this one as a negative end, this one as a positive end. So the electrons are flowing like this. Now try and pause the video and try and do it by yourself. So welcome back. So now if you gonna put your thumb in the downward direction, and then your palm might end up your facing your eyes. So this is my hand. Okay, I'm gonna try and draw. Please pardon me for my drawing. Okay, this will be the back of your palm. Okay, now try and curl your fingers. Whatever direction your fingers will gonna get curled, that will be the direction of electric field. So it will be in this direction in that scenario. So it's gonna move like this. That's the direction of a magnetic field, shall I say. Okay, so hopefully you were able to understand the left hand thumb rule. Now the left hand thumb rule can also be used in another way. So if this was a straight wire in which the electrons were flowing, and now we have a wire in which is coiled form. So if it is in this format, coiled form. So this is how the coil is. All right. And which direction the magnetic field will be. Surely there will be a magnetic field, whether it's a coil or it's a straight line. It's just that the direction of the magnetic field will be different. So as long as the electrons are moving, there will be a perpendicular magnetic field always. All right. So now, again, I'm going to use the left hand thumb rule in this case. But what's going to happen is the electrons will be represented with the curling of fingers. Now, as I said, if you have a coiled wire, the curling of fingers will represent 1, 2, 3, 4. All right. Hopefully, thank God I haven't drawn the 5 fingers and the thumb. Otherwise, you're gonna say he might have studied different bio. Yeah. Anyhow, whatever it is. So these are the electrons. Okay, and this is the thumb. And the fingers are representing the flow of electrons. So curl your fingers in whatever direction your fingers are getting curled. That will represent that will be the direction of the electrons. Means whatever direction electrons are flowing, you will curl your fingers in that direction. So in this case, electrons are flowing from here, from the down to the up. So it's going like this. The electrons are flowing in this direction, in this direction. All right, like this. So curl your finger towards your facing your palm. Again, your palm should face, this is palm, should face towards your face. And now curl the fingers, and the fingers will point towards your face. Okay, once you're going to curl them. So that is the direction of the electron. So electrons are moving like this in this coil. Now your thumb will represent the magnetic north. Magnetic north. Magnetic north. So what I'm going to do here is I'm going to erase this. I'm going to draw a artificial magnet inside this coil, and thumb, as I said, thumb is pointing up. So this is magnetic north. Automatically this will become south. And if I reverse the direction, if the electrons are flowing in this direction downward here, then down here you will have the magnetic north. All right, so hopefully you were able to understand how the left hand thumb rule works. And if you have any questions, you can always ask me. Now the next thing which I'm gonna, okay, here also I can see with this picture also, if the electrons are flowing in this direction, then I will curl the fingers, well, in this, because it's a linear direction. The electrons are flowing in a linear direction, so the thumb will represent the flow of electrons. So curl your fingers. The curling of fingers will represent the flow or the magnetic field. The curling of fingers will represent the magnetic field in this direction. So hopefully this is actually a very good diagram. This will give you a really good education about how the left hand rule works. Now in this is a coiled form. This is coil. So what's happening? The role of the fingers will change with the thumb. So now the fingers will represent the flow of electron. Flow of electron. And then this thumb will represent the magnetic north. So if I try and draw a north pole in this one, so this is how I can draw it. This is magnetic north and this is south, and magnetic field lines will come out of here, go towards inside here. That's how you can represent the magnet for a coiled wire. All right, so hopefully you were able to understand the left hand thumb rule. Now, the next thing which I'm going to talk about is left hand rule. Left hand rule. So left hand thumb rule. The previous one was, if I can see, left hand thumb rule. This rule is different from the left hand rule. So what is the difference? In this case, we were talking about there is flow of electron, and the flow of electron will produce the magnetic field, and we wanted to identify in which direction those electrons are moving. That's what we figured out with the help of Oh no, we wanted to find out the direction of the magnetic field, and we, with the help of left hand thumb rule, we were able to find out the direction of the magnetic field. All right. Now, with the left hand rule, how does this gonna work? If you place a moving electron in an external magnetic field, then we will use the left hand rule. Previously, electrons were flowing. Okay. And with the help of left hand thumb rule, we were able to find out the direction of magnetic field produced by the flow of electron. Whereas now, if you place moving electrons in an external magnetic field, this is a magnet which has its own magnetic field. Starting from north, magnetic field lines goes towards the south. In that case, we will use left hand rule. Hopefully you were able to understand what is the difference between the two. Now we will try and understand how the left hand rule works. Your nails will always represent the direction of magnetic field, B vector. This is the representation for magnetic field. Magnetic field is always represented by B vector. Okay. So direct the nails will always point, or the fingers will point the direction of magnetic field lines, and your thumb will point towards the flow of electron, and your palm will represent the force felt on the electron. So if an electron which is moving in a straight line and you place it in an external field, and you can try and do this experiment, but make sure you are not playing with the current. You try and use only the batteries. Okay, don't use the 120 volt system, which the electricity which runs into our house. Try and use the batteries if you wanted to. If you place a wire in an external magnetic field, that wire will move up or down depending upon in which direction electrons are moving. If the electrons are moving in this direction, the way showed in this diagram, based on that, that wire will move in the downward direction. So it's gonna go like this, downwards. That's how it will flow. Okay. Now, if I reverse the direction of electron, then it's going to start moving in the upward direction, because then, according to the left hand rule, everything will change. Also, palm will come in the upward direction. Now, another thing which I wanted to tell you, the beauty of this is that you need to have two things. What did I talk about? I talked about motion, electron motion, and second thing I talked about was the magnetic field, and then the third thing was the force felt. If you have any of the two things, you will be able to predict the third thing. Either you have these two things, you will be able to find the force felt. If you have magnetic field and the force felt, you will be able to make the electrons move. And that's what happen in generators. How the electricity is produced with the help of generators. So what they do is, I'm going to give you a basic principle. This is a coil. There is a lot more to this, but I'm just giving you a basic principle. This is a coil. If the electrons are flowing like this, in this direction, electrons are flowing. Now, if I place this wire in an external magnetic field, this is a magnet. This is north and this is south. This is south. The magnetic field lines are coming out of the north, moving towards the south. These are magnetic field lines. Now, if I rotate, if I place a rotor here, okay, and somehow with the help of water falling from the height, I start rotating this coil. What's gonna happen? This coil will start rotating. If this coil is rotating, then these electrons will start moving. Okay, and I want to find out in which direction the electrons will move. I can find out with the help of left hand rule. So again, I'm trying to draw the left hand of mine, and this is my palm. Okay, this is palm facing towards your face. I will place my fingers in this direction. This is the magnetic field. All right. And then force felt is upward because I'm rotating it in clockwise direction. If I'm rotating in this clockwise direction, so it means this is going up, this is going down. Okay. So force felt is upward here on this. I'm trying to focus on this section now. Okay. Right now. If force felt is upward, electron will move in which direction? Electron will move into the screen like this. That's how electron will flow. Electrons will flow in this direction. And then obviously they're going to go down here and going to come out on this side. Okay, because the force is down here, and that's again, if you see down here, the force is down here. Here, force was up and force is down here. Okay, in the downward direction. So what's going to happen in that scenario? That electrons use your left hand rule. The palm's going to start facing in the downward direction, and electrons will flow towards you. This will be the direction of thumb. Okay, and this is called generator effect also. Generator effect. Now you can apply this thing on the motor effect. What happens in case of motor? In case of motor, you provide the electricity, you provide the motion to the electrons, and you wanted to find out how this coil is going to rotate. So here I'm going to redraw it. This is a, whoops, let me redraw it. So this is a coil, and the electrons are flowing like this. I've given the direction to the electrons, and here there is a shaft which is attached to the system, and I placed a magnetic external magnet here, north and south. Electrons are flowing in this direction. Use the left hand rule and try and figure out in which direction force will be felt. So on this side, force felt will be upward, and this side the force felt will be downward. That's going to cause the motor to rotate. Okay, so hopefully you were able to understand the motor effect and the generator effect. This is really important from the concept and the exam point of view. Motor effect versus generator effect. Generator effect. So in motor effect, the simple idea is you try, and what happens in motor effect, what we're trying to find out is the rotation, means we get the mechanical energy. In simple words, if I have to say, in motor effect, electrical energy is converted into mechanical, because the shaft is moving in this case, and other way around in generator effect, mechanical is converted into electrical. That's it. That's the difference between the two. So hopefully you were able to understand the difference between these two. If I left something, I'll try and cover that in the next video. This video is already getting a little longer, so I'll see you in another video. Till then, goodbye.